Okay, class, welcome back. So now we're going to be trying to find the area of quadrilaterals. And it's important to remember that a quadrilateral, it's a polygon, like we were just working with, that has four sides. Okay? Quad means four. All right. So if you look at these figures here, if you want to find the area, you might first think, well, let's just try to count the little boxes. But if you look here, you can see we have just parts of boxes. Like this is maybe like a half of a box, and this one here, that's not half. It's hard to say exactly what fraction of the box that actually is. We're have a very hard time figuring out the area if we actually try to use that approach. So instead, what we want to do is we want to see if we can break these polygons apart into figures that we know how to find the area for. So we know how to find the area of a rectangle, and we know how to find the area of a triangle. So if we can break these up into those kind of figures, then we can just find the area of those figures and just put them together. So, for example, in figure A, watch this. If I connect a couple of vertices, look at what I'm going to have. If I connect those there, you should be able to see two triangles, right? So if we just find the area of each of the triangles and then put those together, that'll give us the area of the quadrilateral. So let's look at the triangle on top here. If I count across, I see a base of 1, 2, 3, 4. So a base would be 4. And then remember, for the height, we need to have a perpendicular angle going to the opposite vertices. So that's here. So it's going to be 1, 2. So we have 4 for the base and 2 for the height. 4 times 2, that's 8. But remember, for a triangle, we need to take half of that. So half of 8 is going to be 4. So we can say that the area of that small triangle on top is going to be 4. Okay, we'll leave that there. Now for the triangle on the bottom, the bigger one, the base is still going to be 4, right? But then for the height, we need to go to the opposite vertices. So from here, we need to count down 1, 2, 3, 4. So the base is 4 and the height's 4. So 4 times 4, that's 16. And then take half of 16, and that's going to be 8. All right, so 4 and 8, we need to put those together, right? So 4 and 8 together, the area is going to be 12. So we would say area equals 12. All right, and then so for triangle B, again, you want to look to see if we can connect some of the vertices and form two new figures. And so I look right here, I can see, what about these two? Let me actually move this text box out of the way. Okay, so if I look here, if I connect these two, well, that would be one way that it could work. There's other options as well, but this one seems to be convenient right now. We just go ahead and connect these two endpoints there. And now I've got a triangle here and a triangle here. So what that means, I'm going to move this out of the way as well. What that means is that we need to find the area of each of the triangles. So we need a base and a height, like we were working on in a previous lesson. And if you see here, when it goes diagonal like this and cuts through boxes, we would prefer not to use that one. If they were to give us the measurement of that, then we could. But if they don't, we don't want to mess with that. But we do see a straight line here that we can use. So this one here is going to be easier to use. So 1, 2, 3. So we could say the base is 3 for this triangle, and the height needs to go at a 90-degree angle, perpendicular line to the opposite vertices. So that's here. So if we count it off here, it's 1, 2, 3, 4. All right, so we said this was 3, and this is 4. 3 times 4 is 12. Okay, and then half of 12 is 6. So this one's going to be 6. Okay, so that's the area for that triangle. Now for the other one here, again, this one's going to be tricky. We don't want to use this one if we can avoid it. We want to avoid it because we don't really know what this measure is going to be, and this one's going to be tricky too. So we're kind of left with this side here to be our base. So let's see, it's going to be 1, 2, 3, 4, 5, 6. And then if we want to get the height, we need to have a perpendicular line from here to the opposite vertices. Here's the opposite vertices, so it's got to go there. So 1, 2, 3, 4. So 6 and 4, that's 24. And then half of 24 is 12. Okay, so this triangle has an area of 6. This one has an area of 12. Put 12 and 6 together, and you get 18. So we can say area equals 18 for that one. Okay, now for the next figure, for C. Oops. Okay, for C. This one could be kind of tricky. What can we do here? Well, there's a couple different things that we can do. So something that I haven't done is break it apart and actually into 3 figures. So this is one thing that we can do. If you look here, watch this. If we connect down here, that's going to be a triangle. And we can do the same thing on the opposite side. We can go through and we can drop down another line right there. And so now we actually have 3 figures. We have a triangle, we have another triangle opposite, and then we have a square, I guess. Looks like it is a square. It's the same on all sides. So we can find the area of all 3 of these as one way to find the area of the quadrilateral. So going just left to right here, this first triangle. Let's see here. We don't want to use that. That's going to be tricky. We could use this, and we could use this, right? So if we said this is the base, 1, 2, 3, that's the base, and then the height needs to go all the way up to here, right? So the height is going to be 1, 2, 3, 4. So 3 and 4, that's 12, right? 3 times 4 is 12, and then it's a triangle. We have to take half of that, and so the area of this triangle is going to be 6. Okay, now if you look at it here, this one looks awfully similar. Is it possible that these would be the same? Let's see here. Straight. So base is 1, 2, 3. Yeah, the height's going to be the same thing, right? It's going to be 4. It's going to be 3 times 4, which is 12, and take half of that. It's going to be 6. So that's easy enough. We can just call that 6 right away because that's going to be the same as the triangle on the left side. So that just leaves us with a square. Okay, in the square we saw it was 4 across and 4 down. So that's 4 times 4, which is 16. And let's see, do we take half of that? No, we do not. It's a square. We do not take half of it. So it's just going to be 16. That's the area of the square. And so now we have 3 measurements, and we need to put them all together, right? 6 and 16 and the 6. So we add those up. We do 6. We do 16 plus 6 plus 6. That's going to equal 28. All right, 28 square units. We'll just call it that way. Get in the habit of using that. They don't give us the exact measurement, but we'll call it 28 square units. And make this a little bit easier to see. Area equals 28 square units. All right. So we said just to find the area of 2 quadrilaterals, but I'm going to do all 6 of them here, so it's easy to see how they all work. Okay. So for figure D, let's see what's going to be easy here. Well, I see right here a little triangle, so let's go ahead and connect these. And oops, I need to use the straight line tool. There we go. So I've got 2 triangles, so I can find the area of the 2 triangles, right? So the top one here, the base is going to be easy to use this, 1, 2, 3, 4. And then the height, it has to be a perpendicular line to the vertices. So we've got to go here, 2. So 4 times 2, that's 8. It's a triangle, so we have to take half of 8. So 8 divided by 2 is 4. So the area of that smaller triangle is going to be 4. And then for the bottom triangle, we can still use this same base for this triangle, right? It's 4 before, it's still going to be 4, but now the height, we've got to go down to the opposite vertices all the way down here. So let's count and see how many there are here. This is 1, 2, 3, 4, 5. Okay, so that's 4 times 5. That's 20. And then we have to take half of that. Half of 20 is 10. So we're going to call that 10. And so if we have 4 for one part and 10 for the other part, the area of the whole thing, we're going to put those together. 10 plus 4, area equals 14 square units. Okay, and then for figure E. All right, let's see here. What can we do? I see a way to make triangles. So let's go ahead and connect these. All right, so that's one way we can do it. So we need to find the area of this triangle. Again, this diagonal line is going to be tricky. We don't want to use that one, but these two we can use. We can call this the base. Let me move this out of the way so it doesn't keep getting in the way. So if we call this the base, that's 2. And then the height has to be straight up here. That's 1, 2, 3, right? So 2 times 3, that's going to be 6. And then we need to take half of 6. And half of 6 is 3. All right, so 3 is going to be the area of that smaller triangle. And then for the bigger one, this we don't want to use. This one we're not going to want to use because it's very tricky. So this has to be our base, as it's easy to count here. So 1, 2, 3, 4, 5, 6, 7, 8 is the base, and then the height has to be a perpendicular line from this base to the opposite vertices. That's here. So 1, 2, 3. So we have 8 across. 8 is our base. 3 is our height. So 8 times 3, that's going to be 24. And then we need to take half of that, and that's going to be 12. All right, so the area of the bigger triangle is going to be 12. And so that's going to leave us then with 12 and 3, and we have to put those together, right? We have to do 12 plus 3, and so we can say that 12 plus 3 means that the area equals 15 square units. Okay, and then for the last figure here, you're thinking, wait, that could be like a square that's kind of rotated. Okay, but again, because it cuts through our grid boxes diagonally, and we're left with just portions of the boxes, it's going to be tricky to be able to count this. That's not recommended as an approach. So the better idea is to go ahead and to break this apart into 2 figures. And I can see pretty easily I can cut this down into 2 triangles, just like that. All right, so if we want to find the base and the height, again, this one and this one, we don't want to use these unless they just happen to give us the measurement. We don't want to try to figure out what the measurement is any other way. So the sure thing is to use this as our base. We can use that as the base for both triangles, right? So for the base, it's going to be 1, 2, 3, 4, 5, 6. And then the height for this top triangle has to go to here. That's 1, 2, 3. So 6 times 3, that's 18. It's a triangle, though, so we have to take half of that. So the area of this top triangle is going to be 9. And wouldn't you know it, the same thing is going to apply to the bottom triangle. It's going to be another 9, right? It's going to be base of 4, base of, 6, and then the height's still going to be 3, 1, 2, 3. So it's still going to be 6 times 3 is 18. Divide that by 2, and you're going to get 9 once again. And so we're going to put these two together. 9 and 9 together is going to be 18. So area equals 18 square units. Okay, hope this helps.